Today we're going to be talking about the trapezoidal rule, which is another way that we can approximate the area under the curve. Instead of squares like we have in the past, we're going to be using trapezoids. So remember that the area of a trapezoid is 1/2 the height times base 1 plus base 2, where the height, and they have it written out here, the height is this distance. Basically, I like to think about that as your delta x. So we have our height there, and then your bases are going to be the actual function values. So your bases are your function values. So let's look at what this ends up being. So the area under the curve can be approximated by height, y0, y1, or I'm sorry, y0 plus y1 over 2. So that's for this trapezoid. And then we move to the next one, y1 plus y2 over 2. And we can keep moving along all the way for all of our trapezoids. Yes, I realize that these are triangles, but you can use the same idea for all of these. And so we get this equation here. Since each of them has the same height, and this is only if they have the same height. We're going to do an example where we don't have the same height. So if we have the same height, you can factor out the height. And then what they did is they factored out a 1/2. Because really what you have going on here is, if you look at it like 1/2, because every equation is going to have a 1/2, every equation is going to have an h. We have two y1s. We would have two y2s, and all the way we would have two y sub n minus 1s. The only term that we have one of is the y sub 0 and the y sub n. So this is how we can approximate using our trapezoids, where again y sub 0 is standing for f of a, the first function value, and then all the way to y sub n is equal to b. So again, our trapezoidal rule can be used to approximate it using this formula. And remember, h, which I again will think about as delta x, is b minus a over n. And this is all if we have equal heights. Okay. One thing that we talk about is that if a graph is concave up. So if a graph is concave up, whether we're increasing or decreasing, it doesn't matter. But if I'm concave up, so there's a graph that's concave up. I'll put in some axes so that we can see. Over our interval, just say we have one big trapezoid in there so we can see it. This is an overestimate of our area. Estimate. And I think I spelled estimate wrong. Overestimate. I don't think so. Okay, so if we're concave up, it's an overestimate. Versus if we are concave down, and again, it doesn't matter if we're decreasing or increasing. It just matters our concavity. So I'm concave down. Drawing in your trapezoid from 2 points. This is going to be an underestimate. In this first example, we have to use the trapezoidal rule with n equaling 4, so 4 trapezoids, to approximate the value of the integral. Use the concavity to predict whether we are in underestimation or an overestimation, then use integrals to find the exact value. So y equals x cubed, remember, looks something kind of almost like a tangent graph. And we're going from 0 to 2. So we're approximating the area under that curve. So we have to figure out the height of our rectangles. So to figure out the height, we do b minus a over the number of rectangles, which is in this case is 4, so our height is 1/2. So we go to 1/2, and we have our first trapezoid. I apologize, I think I keep saying rectangle. Our second trapezoid, go to 1.5, and we have our next trapezoid. And I wish I would have exaggerated this graph a little bit so you could see the trapezoids that we have drawn in there. So remember that the formula for a trapezoid is 1/2 the height times the sum of all the bases. And we're going to have a whole lot of bases here. But remember, this first trapezoid here, our first base, I'm going to accentuate it. I realize it's 0, but this first one is f of 0. And we add to that the second base, which is whatever f of 1/2 is. But then for this next trapezoid, one of our bases is 1/2. So that's why we have 2 of those 1/2s. And then we would have an f of 1. For the next trapezoid, f of 1 shares that base. So that's why we have 2 of those f of 1s plus then f of 3/2. Oh, I didn't give myself enough room. I apologize if you can't see. I will erase a little bit and give us a little bit more room. And then our last rectangle, let's see if I can get a different color in here. Our last trapezoid shares that common base. So we have 2 of those and only 1 of the last thing. And so now it's just a matter of evaluating. So we have 1/4. F of 0 is 0. 2 times 1/8 plus 2 times 1 plus 2 times 27 over 8, and then plus 8. And I'm not going to go through simplifying all that math for you guys. You guys are calculus students. You can simplify by now. But when we simplify all that, we get 17 over 4. Now again, remember to figure out whether or not it's an overestimation or an underestimation. We look at the concavity of our curve. So our first derivative would be equal to 3x squared. Our second derivative, which is where we look for our concavity, is 6x. On that interval, f double prime of x is greater than 0 on our interval from 0 to 2. Technically, it's equal to 0 there, which means we are concave up, which is going to be an overestimation. So my curve is actually kind of drawn really poorly down here. I was drawing them underneath. They should have been drawing them above. Lastly, they asked me to find the exact value. So going through the exact value, using our fundamental theorem of calculus, 0 to 2 of x cubed dx. The integral of that is 1/4 x to the 4th, evaluated from 2 to 0. So I have 2 to the 4th, which is 16 over 4, minus 0. So our actual value is 4. If you think about it, this is greater than what I got, so it is an overestimation. Oh, I should have written over here, overestimation. Okay, in this example, we're given a test rocket and we're given a set of values. This is what you're going to find a lot on the AP, so keep that in mind. So you're going to be finding examples like this. Notice that your difference in your x's or your heights are each a different interval. So you're going to have to keep in mind here that your heights are different for each one. So you have to calculate each one of these individually. So 1/2 my height, the difference between my x values, which is 20, base 1 plus base 2. And I did that in my calculator, we got 0.3. My next one, 20 minus 60, so my height is 40, base 1 plus base 2. And again, I used my calculator and I got 2.2. Next, between 60 and 90, 1/2, my difference there is 30, and then base 1, base 2, and again, using my calculator, next one is 1/2, the difference between 90 and 120 is 30, base 1 plus base 2, and calculating in my calculator, we get that. The next one, I apologize if the yellow is kind of hard for you guys to see. The difference there is 20, base 1 plus base 2, and then lastly, 1/2, my last base is a difference of 40, base 1 plus base 2, and in this case I get 21.4. Now I add all those together and we end up with 40.85, and we want to know how long. Okay, number of miles it's traveled. I give us units, so give me units back. Okay, please make sure the lesson summary below this video is submitted on time.